Hello everyone and welcome to another video on building serverless applications on AWS using .NET. Today we're going to continue right from where we left off in the last video, and that is running minimal APIs on AWS Lambda. However, in this video we're going to do that using native ahead of time compilation and .NET 7. And by the end of this video, you'll know everything you need to do to get a minimal API running on AWS Lambda with ahead of time compilation. Now, before we dive into the example, I just want to call out that Microsoft do not currently officially support ASP.NET with native ahead of time compilation. So what we're looking at today is technically possible. It will run on Lambda and it will be functional, but we might not quite yet get the full feature set of ASP.NET, and there might be some features that get broken when the ahead of time compilation happens. But we'll dive in anyway and we'll have a look at how to get this working and also the performance impact of doing this. So to start with, we'll take an existing minimal API that we already have set up to run on Lambda. So you see in our startup class for this minimal API, we've already got the line of code to add AWS Lambda hosting. This is what we had in the last video. And then if I just go and look at the API itself, if we actually have a look at the function code, you see our API has got 4 endpoints for getting, creating, and deleting products. So we've got a get endpoint to list all of the products. We can delete product, we can create a product or update a product, and then also get a specific product. So this is the application code we're going to pick up, and we're going to run this on Lambda with native ahead of time compilation. So the first thing we'll do to get started is we'll actually update our project to use .NET 7. So if we open up the csproj file, we will change that to be .NET 7, and we'll just add the additional properties we need for ahead of time compilation. So we'll add the publish AOT property, we'll add the strip symbols property to strip out some of the debug symbols, and then we'll also set the assembly name here to be bootstrap, because remember, if you look at my other videos on NativeAOT, because we're using a custom runtime with Lambda, the custom runtime looks for a file named bootstrap and uses that as the entry point for the application. So when we output this compiled application, it needs to be called bootstrap. So we've got that set to bootstrap there. And we'll just do the same in this shared library as well. If I just edit the project file over here, and we'll just bump this version here to .NET 7, and we'll also actually need to make this ASP.NET Core Server hosting version 1.5.0. So it's this version 1.5.0 that was released last week that has an additional feature to enable this capability to run native AOT compilation on Lambda. So let's start and have a look at what that additional feature is. So if I look at my startup class now, and we just zoom in a little bit, we've got this line of code here for adding AWS Lambda hosting. Now with version 1.5.0 and later, we actually get an additional configuration option here. So we can use this options setting to actually set a serializer. And what this allows us to do is set a custom source generated serializer for our application to use. So I can set that there, and I can do options.serializer, and we need a new source generated serializer, and that's where we're actually going to pass in our serialization context. So if I just create a new class now in my project, and I'm going to call this API serialization context, we will make this a partial class, and we'll have that inheriting from JSON serializer context, and then that API can then pop straight in there. If you're not familiar with source generated serializers, I'll put some links in the description for what they are, how to configure them, and also to my other videos on NativeAOT, so you can see how this works. But what we do with this serialization context is we set the types that we need to be serializable. So we have our product object that gets returned by the API, and we also have a product wrapper object that gets returned by the list endpoint. And the other couple of options we need to add are the actual API gateway proxy requests. So although we're not using these API gateway payload objects directly, under the hood, the tooling that this AWS Lambda hosting uses does actually use the mapping of them events. So we still need them event payloads to be serializable. Just forgot to put my new keyword in there. So that's all we need to do to add serialization for the AWS tooling. The other thing we can just do in our actual startup class is that I can actually in here set builder.services.configure HTTP JSON options, and if I pass some options in here as well, we can actually tell ASP.NET to use the source generated serializer as well. So I can say options.serialization options.add context, and I can actually pass that context in there as well. So now when ASP.NET performs JSON serialization and deserialization on our behalf, it will also use that same custom serialization context. Now this is a useful thing to do even if you are not using native ahead of time compilation, because source generated serializers it generates classes at compile time to do the serialization and deserialization, as opposed to the typical method which uses a lot of reflection. So this actually in a lot of cases will be more performant if you want to do this additional configuration. Okay, so the next thing we need to do is manage some of the trimming configuration options. And again, if you've seen my other videos on NativeAOT and Lambda, in the past we've used the rd.xml file to perform this, to control which assemblies are being trimmed by the compiler. But what we can actually do is if we edit our csproj file, we can actually do that natively in our csproj file now. So if I add a new item group here, and I can use this trimmer root assembly option, and I can say include, for example, AWS SDK.core. And this is now going to tell the compiler that this AWS SDK.core assembly is what's known as a root assembly. And that means that it actually will be excluded from any trimming. The other thing we can do to actually control the trimming is to set the trim mode up here to be partial. And if we set the trim mode to partial, the compiler will look at all the assemblies, and if an assembly is marked as trim friendly, it will trim it. If it's not, it won't. If we take that out, the default here is trim mode of full, and that will trim everywhere except where we exclude specific assemblies in this item group. And that's the approach we're going to take. So we're going to let the compiler trim as much as possible, and we're going to specifically tell it which bits to exclude. So rather than watching me type all of these things in manually, I've actually got some code I wrote earlier, and we'll just paste that in there. So actually what we're excluding here is any of the AWS libraries, because currently none of the AWS libraries are trim friendly. And we're also excluding our shared library as well, just to make sure that none of our JSON serialization code gets trimmed out after compilation. So that's everything we need to do there to actually enable native ahead of time compilation to exclude some of these assemblies from trimming. And this is very similar to the approach of the RDXML file. It's just a slightly different way to doing it and more clean. So now let's go and actually have a look at our API code. So if we open up our application code now, it's actually tidy up some of this code a little bit. So instead of having all of these handlers in line, I'm actually going to switch this around slightly. And what I'm going to do is introduce a static class at the bottom here. We could put this in a new file, but for simplicity's sake, we're going to have it here. And I'm going to create a new static async task, and I'm going to call this delete product. And this delete product endpoint is going to take in our HTTP context, and we'll pass that down like that. And this is actually going to be our API endpoint now. So if I go up to my delete product endpoint here, which is this one here, I'm going to grab all of the contents out of there and actually drop that into my delete product method. And we just tidy that up a little bit more. And then our actual handler code at the top here, it becomes a lot simpler because we can now just call handlers.delete product, and we can use that just as a, oh, did I not make that a public method? No, I didn't. Let's make that a public static async delete product. And now we've just got this really simple delete endpoint where we're saying map this root with an ID property to our delete product endpoint, and now we've got this really clean and easy to read these really clean and easy to read API endpoints. I'm just going to quickly move the rest of these into classes now. You don't need to watch me do that. I'll be back in just a second. Okay, so I've moved all the methods over now, and you can actually see our API definition is really quite simple. We've just got our endpoints, and we've got a specific handler per endpoint. It's really clean, really easy to read, and really easy to understand. So if we now look at some of our endpoints, however, we've got some issues here where perhaps we were using the logger from an actual app. Our data access property no longer exists anymore. So what I'm just going to do is introduce a couple of additional properties here. So we're going to have our data access property. We'll make that internal, and then we're also going to have an internal static logger, and we'll call that logger. We've got that there, and then up at the top here we can actually just say handlers.dataAccess, and then handlers.logger equals our app logger for purposes of this example. Now we could of course move all this into services, and we could use proper dependency injection. For the purposes of this simple demonstration, we're just going to do it this way and set the properties. And then we just need to come into here. Everywhere we've got app.logger, I'm just going to do a find and replace here, and just replace that with the word logger, and that will then fix all our errors. So you see now we've got error-free code, apart from this section here where we've got our product. So previously our product was actually coming in, and we were letting ASP.NET do some of that mapping on our behalf like that. Now what I'm actually going to do instead is I'm going to show you how you can parse that from the body. So the first thing we need to grab is the ID. So if we look at the context, we look at the request, and we look at the root values, we can actually grab our ID property from there. So that's got us our ID. And now our product, we actually need to parse that from the body. And we can do that using our JSON serializer, and we want to deserialize to a product object. And we're going to take that from the context.request.body. Now, of course, we're using source generated serializers here, right? So we actually need to specify our source generated serializer, and we can do that using our API serialization context, the default instance, and then our product class. In some IDEs, this will show us an error. Remember, these source generated serializer generated at compile time. So a class does not actually exist right now, but that's fine. When we build this, it will build okay. I promise that will work okay. Now the final thing we need to just change in all of these methods is that before we were returning our results, but obviously we've just got this task now. We don't actually need to return anything, so we can just set that to do results.badRequest, and this results.badRequest method will actually set all of the relevant status codes and all that really useful stuff that we need, but it does that in a really succinct way. And we can do the same here where we're setting our OK status code. We don't actually need to return there, and the same here for our bad request. So now we've got all our methods, and this is all ready to go. We can do the same here. So previously in our get products, where we were writing the JSON manually, because in our startup class we've actually told ASP.NET to use our serialization context, we can just simply replace that with a call to results.ok and pass in our products object. The same again up here when we're getting a specific product, we can just do results.ok, pass in our product object, and then again up at the top here we've just got a string coming out there. Again, we can do return, don't need the return, we can do results.ok, pass in our string message that we want to return, and down here we can just replace that with a not found. And there we are. Now we've got a really simple minimal API. It's really easy to read and understand. It'll help if I use the right property there. And then we've got these separate handler methods for each of our API endpoints. And again, we're just we're not actually returning anything. We're just setting all of the response status codes and the body and the content type. We're doing all that manually, but doing that in a succinct way using these results.notfound. Now, one of the things that might cause us a problem here is that we're actually parsing this ID value out of the request, but we're kind of doing that in a custom method. So how can we kind of prevent that? Well, there's a new feature that's come to .NET 7, which is endpoint filters. So what I can actually do here underneath my map get is I can create a, let's call it a specific product endpoint group. and I can say app.mapGroup, and I can say I want to map a group of endpoints all under the ID. And what I can add here is an endpoint filter. And what this endpoint filter will do will actually hook into the middleware pipeline of ASP.NET, and before any of these methods are invoked, it will actually we can add some custom logic to all of these endpoints. So we'll come back to that in a second, but what I just need to do here is replace all of them endpoints. So rather than mapping our delete endpoint to the root of the app, we're actually mapping it to that group of endpoints, and we're saying, the base of this /ID endpoint here, we're going to map delete, map put, and map get. Now, what about this endpoint filter? So what we can actually add, if I come back below my handler class here, I can add let's call it an ID validation filter, if I could spell, and that's going to inherit from our endpoint filter. And then in there, and then we just need a single value task here, and we've got this invoke async endpoint, and this is where we can actually apply our custom logic to validate all of these endpoints. So if I just go back up and add my ID validation filter there, you see we've now got this endpoint filter. And if I come down to the bottom again now, we can actually implement some logic here to try and do this. So if I now try and parse my ID out from, say, context.http context.request.root ID, and now we've just got a nullable object, and I can now say if the ID equals null, then we're actually going to return a results.validation problem. And this validation problem allows us to create a new dictionary of strings, string arrays, and we can actually now create these errors. And we can say the error is on the ID property, and then our actual error itself is just that ID not found in this root, for example. Just had a semicolon there, and we just need to make this an async method now. And then if we are happy, if the ID isn't null, we can just then say return next context. Return await next context. And that's actually then going to move on through the middleware pipeline, and we can move on to the next part of this request. And I've actually already created a SAM template just to move this along a little bit. So if I add a new item to my API Bootstrap project, I've actually got a SAM template here ready to go. Just add a link to that there. And this SAM template just defines a single Lambda function, because we only need one Lambda function because all our routing is going to happen in ASP.NET. Obviously our code URI is this API Bootstrap endpoint, and then we're specifying we want a HTTP API in front of our Lambda function, and we're going to use this proxy route with an any method, and what this will do is tell API Gateway just pass every single request onto our Lambda function, and the routing will be handled by ASP.NET. We're also creating a Lambda with a custom runtime. We're using x86 as a base architecture because we can't use currently .NET 7 and NativeAOT on ARM, so we have to use x86. And then we're just setting a couple of other environment variables. I'm going to go off and deploy this to AWS now. I'm going to pause the video while I do that because NativeAOT compilation can take a little while. I'll be back in just a moment. Don't go anywhere. So that has finished deploying now, and if I just take a copy of my API endpoint and flick over to my web browser, and I'm going to hit this API endpoint for the very first time now, and you can see just how fast that cold start was. And if we just open up the network tab now, just to demonstrate that this is actually a successful request, if I hit that again now, you see we're getting 200s. Obviously there's no products in our database at the minute, so we're actually not getting anything back. So you can see just how quick these responses are coming back. We've got 68 milliseconds there. This is warm, of course. But if I flick over to my CloudWatch logs now and go to my CloudWatch log group, and we have a look at the first request back in this pipeline, the one that actually triggered the cold start. And you can see we actually have the init duration here. And the init duration of this Lambda function, the cold start of this minimal API, is 470 milliseconds. Wow, that is fast. Like the typical duration we were seeing for .NET 6 and managed runtimes, if you go and look at the AWS benchmarks, is about 1.2 seconds at P50. And if we get up to P99 and the P max, we're talking 1.5, nearly 2 seconds. Now, I know this is a sample size of 1, and I am going to publish some full benchmarks on the AWS benchmarking repository. I'll link to them in the description. This is fast. We've got a fully fledged minimal API running on Lambda now with a cold start duration of 473 milliseconds. That is a massive improvement over what we got for .NET 6. So let's just cover back now some of the things we had to change and we had to edit to actually make this work, just to recap. So the first thing we had to do was, of course, update everything to be .NET 7, and we actually enabled the publish AOT property, and we set the assembly name to Bootstrap. This is to enable the custom runtime on Lambda to actually invoke our Lambda function. We configured all of the assemblies we wanted to exclude from trimming. At the moment, this will include any of the AWS libraries that you're using, any of the SDKs, X-Ray, of course, the API events payload, because we want that payload to be mapped successfully by the AWS tooling. And then if we open up our startup class, we updated our add AWS Lambda hosting line to actually set the serializer to be the source generated serializer, and we also configured ASP.NET to use our custom serializer as well. If we just take a quick look at this custom serialization context, just to round this out now, we've just created a new partial class inheriting from the JSON serializer context, and then we've specified all of the types that we want to be serializable or deserializable, in fact. That includes the product and the product wrapper, the custom classes in our application, and then of course the HTTP API request and response. And like I said earlier, although we're not using them directly in our application, the AWS tooling that sits behind this add AWS Lambda hosting that maps the API gateway payload to ASP.NET does actually need to be able to serialize and deserialize our actual event payload. That is what we are doing here. And that's it. Now we have a minimal API running on AWS Lambda with .NET 7 and NativeAOT. And we've actually also enabled some of the new features of .NET 7 to add these endpoint filters to centralize our validation that our ID actually exists. And we've abstracted some of these actual endpoint methods into specific methods just to clean up this code a little bit and give things a bit more of a single responsibility. That's all today. Just as a reminder, Microsoft do not officially support this in .NET 7. If you try and run this in production and you have issues, neither AWS nor Microsoft can support you directly. Of course, we can help and debug, but this is not a supported feature by Microsoft. Although, as we can see, it does actually work on AWS Lambda, and it is pretty fast. That's all for today. As always, any feedback, please let me know. If you've enjoyed this video, please like, please share, please subscribe, and I will see you all next time. Thanks for watching.